3, 2, 1.
In this episode of Science for a Self-Reliant India, we take an in-depth look at India's space program and the achievements of its space agency, Indian Space Research Organisation, or ISRO. In less than 60 years, India has become a world leader in space technology and exploration. The program began in 1962 under the leadership of Dr. Vikram Sarabhai. It was then a part of the Department of Atomic Energy.
He thought that here is a very unique technology, a technology that needs high levels of development in terms of capability. It also brings the teamwork culture among the people, and we need to create new institutional mechanisms by which this can be progressed, which are all new to India but very essential for India to take the next step, what you may call as a leapfrogging from the state of lack of development to development. So that is the reason why Sarabhai thought we should have a space program which is more tuned to the needs of India than the Western world, which is already developed.
India's vision in establishing the space program is to harness space technology for national development while pursuing space science research and planetary exploration. The track record of India's space agency speaks for itself. Engineers and scientists of ISRO have designed and developed a range of launch vehicles for putting into space indigenous satellites and related technologies for Earth observation, communication, navigation, meteorology and space science. Important initiatives of ISRO have included development and launch of the Indian National Satellite System, or INSAT, for communication, broadcasting and meteorology. The IRS, or the Indian Remote Sensing Satellite System series, to support the national economy in areas of agriculture, water resources, forestry. And importantly, the development and operationalization of the Polar Satellite Launch Vehicle (PSLV) and the Geosynchronous Satellite Launch Vehicle (GSLV) for launching not only Indian but international satellites into space.
Effectively, because the purpose was to see that yes, we can put a satellite in space and control it. That was the purpose. Then we came to applications. Next step was to use it for meteorological applications. So we launched a satellite called Bhaskara 1, Bhaskara 2, mostly for meteorological and oceanographic applications. That was the basic starting point of satellite technology for applications. Then we had other applications, IRS, Indian Resources Satellites, then we have INSAT satellites, all those things followed. But these are the very significant satellites that were launched.
India has also achieved success in important space exploration initiatives like Chandrayaan, Mars Orbiter mission, also known as Mangalyaan, and the launch of AstroSat. But the next few years are going to be even more eventful and path-breaking for ISRO and indeed our country. Preparations are underway for launching a 3-member Indian crew to space for a period of 5 to 7 days and safely return them to Earth. This and much more on our 2-episode series dedicated to India's space program and ISRO as we celebrate 75 years of India's independence on our show Science for a Self-Reliant India, only on India Science. Among the most remarkable achievements of independent India in the last 75 years has been the development of its space program, which started under the leadership of Dr. Vikram Sarabhai and physicist Kalpathy Ramakrishna Ramanathan in 1962. It was named the Indian National Committee for Space Research, or INCOSFAR, which was renamed in 1969 as ISRO as we know it now. At a time when India is working to send its first manned mission to space, the initial years of our space program stand in contrast. It's difficult now to imagine that India's first test rocket in 1963 was transported for assembly to the launch site in Thumba, Kerala on a bicycle. Preparation for India's first test rocket flight, the US-made Nike APACHE sounding rocket, began with basic resources and a small but dedicated pool of scientists like Puneet E.V. Chitnis, who had left his lucrative job in Massachusetts Institute of Technology, Cambridge, USA, and a team of rocket engineers, which included Dr. APJ Abdul Kalam, who would go on to become India's president from 2002 to 2007. The Indian space program really took off in 1963 with the launch of the Nike APACHE sounding rockets from Thumba in Thiruvananthapuram in Kerala state on November 21st, 1963. This two-stage US sounding rocket weighing 715 kilograms reached an altitude of 207 kilometers during the test flight. The launch site, which is now called the Thumba Equatorial Rocket Launching Station, was selected as it is very close to the Earth's magnetic equator. After 4 years of this launch, on November 20th, 1967, the first indigenously developed sounding rocket, Rohini 75, with a total weight of 7 kilograms and a length of 1020 millimeters and a diameter of 75 millimeters, was launched, and it reached an altitude of 9.3 kilometers. And this was the beginning of the era of Indian rocketry. To accelerate space research, the Indian government reached out to a number of countries for collaborations. These included the United States, the erstwhile USSR, France, the United Kingdom, and even West Germany. The main focus was to procure advanced technical equipment for the rockets such as telemetry receivers, tracking systems, and computers. In return, India dedicated the Thumba Equatorial Rocket Launching Station, or TERLS, to the United Nations as a goodwill gesture in February 1968.
It is not accidental that on the soil of India, the great space powers, the United States, the USSR, and France, are collaborating with us at the equatorial range near Thumba.
As a result, a number of international launches also took place from Thumba, like the Rohini series of sounding rockets, and a number of foreign rockets like the M100 from USSR, Nike APACHE, Nike Tomahawk, Ericas and Judy Dart from the US, Centaur and Dragon from France, Suki 1 and 2 and Petrel from the United Kingdom were also launched. Regarded as the father of the Indian space program, Dr. Vikram Sarabhai was born on August 12, 1919 in Ahmedabad. Dr. Sarabhai was a physicist by training and attended Gujarat College and then Cambridge University. During World War II, he returned to India and joined the Indian Institute of Science in Bangalore under physicist Sir Chandrasekhar Venkataraman. In 1945, he went back to Cambridge University to pursue a doctorate and wrote a thesis, Cosmic Ray Investigations in Tropical Latitudes, in 1947. On his return to India, he founded the Physical Research Laboratory in Ahmedabad. In 1962, Dr. Sarabhai established the Indian National Committee for Space Research, which was later named the Indian Space Research Organization, or ISRO as we know it now. Sarabhai also set up the Thumba Equatorial Rocket Launching Station in southern India. After the death of Dr. Homi Jahangir Bhabha, widely regarded as the father of India's nuclear science program, in 1966, Dr. Sarabhai was appointed chairman of the Atomic Energy Commission of India. Here, Dr. Sarabhai helped develop India's nuclear power plants by laying the foundations for the indigenous development of nuclear technology for defense purposes. Dr. Sarabhai believed that science and technology were important tools to bring development to even the most remote parts of India. He worked on programs to take education to remote villages through satellite communication, and called for the development of satellite-based remote sensing of natural resources as well.
We had our own visionary who thought this new access for the humanity, for the vantage point of space, could have very unique possibilities for India in view of its development status and in view of the use of new methods of improving the various systems which are critical to the national development and endeavor. So that was the background in which Dr. Vikram Sarabhai, the India space pioneer, thought of possible impact of this new development in the context of the development of this country, especially in the social, economic, cultural milieu. He thought the satellites, for example, when they go around the Earth, they can be used for communication as a tall tower. He envisaged that if the satellites go around the Earth's orbit, it can take pictures of the ground, and those pictures can be used for providing timely, accurate, and precise information. He saw here is a new opportunity for exploring the outer space by sending instruments through the space, to the satellite, to various locations in the space. And thus he thought that here is a very unique technology, a technology that needs high levels of development in terms of capability. It also brings the teamwork culture among the people, and we need to create new institutional mechanisms by which this can be progressed, which are all new to India but very essential for India to take the next step, what you may call as a leapfrogging from the state of lack of development to development.
Post-independent India saw the country building capacities in science and technology. The objective was to establish our nation as a world leader in new technologies and scientific knowledge, so that this knowledge and the tools could also be harnessed for development purposes. Now, to achieve these objectives, it was decided to administer various programs like space, atomic energy, scientific research programs in a more cohesive and coordinated way by establishing a full-fledged Science and Technology Ministry in 1971. While in June 1972, the Government of India constituted the Space Commission and established the Department of Space and brought ISRO under it. As a result of this important thrust, the decades of the 1970s and the 1980s marked an important transition in the history of India's scientific and technological journey. The Ministry of Science and Technology was thus established in 1971. The aim was to formulate and implement science and technology policies, as well as to streamline research agenda and to establish science and technology infrastructure in the country. Besides promoting international cooperation, the ministry facilitated funding for domestic institutions and research programs. The emergence of the ministry gave a push to the already existing research and development programs in the country, such as the Green Revolution, and helped to give a major boost to some of the new programs and institutions such as space research and the nuclear program. Although India's space program owes its birth to the vision of Dr. Vikram Sarabhai, it was Dr. Satish Dhawan who helped transform ISRO into a world-class space organization. Dr. Satish Dhawan graduated from the University of Punjab with an unusual combination of subjects: a BA in mathematics, an MA in English literature, and a BE in mechanical engineering. In 1947, Dhawan left for the United States to pursue higher studies in the University of Minnesota, from where he obtained an MS in aeronautical engineering before moving to the California Institute of Technology, or Caltech, for a degree in aeronautical engineering. Dhawan followed this up with a PhD in aeronautics and mathematics from Caltech in 1951. In the same year, Dhawan joined the Indian Institute of Sciences, Bengaluru, as a faculty member and was appointed its director in 1962. In 1972, he succeeded Vikram Sarabhai as the chairman of Indian Space Research Organization. It was under his leadership that India launched its first satellite, Aryabhatta. His efforts led to operational systems like INSAT, a telecommunication satellite, IRS, the Indian Remote Sensing Satellite, and the Polar Satellite Launch Vehicle PSLV that placed India in the League of Spacefaring Nations. Dhawan remained the chairman of ISRO till 1984. ISRO's first success came when Indian scientists launched the first satellite into space on April 19, 1975. Named after the ancient Indian astronomer Aryabhatta, the satellite was completely built and fabricated in India and was launched into space by Cosmos 3M launch vehicle from Kapustin Yar, the then Soviet Union's rocket launch and development site. Aryabhatta was built with the aim of gaining experience in building and operating satellites. The satellite weighed 360 kilograms and was also equipped with a suite of instruments to conduct experiments in X-ray astronomy and solar physics. The satellite was designed as a 26-sided polyhedron with a diameter of just over 4.5 feet and was powered by solar panels. In the same year, in August 1975, another indigenous space project called Satellite Instruction Television Experiment, or SITE, was launched by Indian Space Research Organisation in collaboration with National Aeronautics and Space Administration, or NASA, of the United States. For the first time in the history of the nation, 2,400 black and white community television sets came alive across 6 states in the country.
The SITE experiment, as I said, is Satellite Instructional Television Experiment, was conducted by the Space Applications Center in collaboration with NASA, and the purpose was to make everyone aware of the major advantages of satellite, because those days, 1975, 45 years ago, it was tough, it was difficult to convince the non-experts or people who are in the administration to spend so much money, whether we should spend so much money for such missions. So there were such comments coming from various places. So Vikram Sarabhai had a very good and correct idea of using satellite for instructional purposes.
This was one of the largest experiments of its kind, with the aim of demonstrating the potential of satellite technology as an effective medium of mass communication for a developing country. Educational programs which were made in India were beamed by the Application Technology Satellite ATS-6 of the United States. The SITE project established that the reach and extension of communications infrastructure to remote areas was not only feasible but an important medium which could be used to accelerate national development.
Who are the people listening to it? Number one, the farmers. The farmers are getting data about the weather, about various educational programs on how to do the cultivation, what are the various topics to be addressed. That is number one. Number two were the students. We selected about 2,500 villages, 2,400 villages all around the country, and made one person in charge of that unit, local unit, and we demonstrated that education, that means classroom teaching, is possible using the satellite. And today all of us know, because of the pandemic, we are going through the instruction via digital method. So this is the one. Long back we had actually we did not anticipate this type of situation, but very effectively we could communicate with very far away, inaccessible places, hilly regions, remote areas, underdeveloped areas. All those things were very effectively reached through this satellite instruction television experiment.
5 years after India launched its first space satellite, Indian scientists achieved another milestone. On June 7, 1979, ISRO launched India's first low-orbit observation satellite, Bhaskara-1, from Kapustin Yar on board Intercosmos launch vehicle. Its mission was experimental remote sensing, It was the first Indian satellite to be put into space for the purpose of studying the Earth, collecting meteorological data, map making and monitoring of the environment. Between 1970 and 1983, another important mission was undertaken by ISRO to design and produce India's first satellite launch vehicle, SLV-1. The chairman of ISRO, Dr. Satish Dhawan, appointed Dr. APJ Abdul Kalam as project director. The first attempt of SLV-1 was only partially successful.
Of course, every program there will be a technological problems will come in. Our earlier attempt in 1979, we had a failure. The SLV-3 could not inject the Rohini satellite in the orbit. But that is in July 1980, it was successfully launched and many successes followed.
So the first indigenously developed Indian satellite was successfully launched into orbit on 18th July 1980 on an SLV-3 rocket from the Sriharikota Space Center in the Bay of Bengal. Sriharikota is a barrier island off the coast of Andhra Pradesh and was chosen in 1969 as India's second satellite launching station. The island covers an area of over 43,000 acres with a coastline of 50 kilometers. The island's close proximity to the equator, which benefits eastward launches of the rockets, also give an important cost advantage to India for launching satellites. As the Earth rotates eastwards on its axis, a rocket launched into orbit gets extra velocity from the Earth's rotational motion when launched in this direction. As Sriharikota is a large uninhabited island, it is also ideal from the safety perspective, making it an ideal spaceport. It was named as the Satish Dhawan Space Center in memory of Satish Dhawan, former chairman of ISRO, in 2002. Sriharikota is considered by many space experts as the second best located spaceport in the world after the Kennedy Space Center in the United States. First indigenously developed satellite was spherical with a 0.6 meter diameter and weighed 35 kilograms. This launch made India the seventh nation to launch a satellite into orbit on its own rocket. In August 1983, the Rohini 3 communication satellite was launched, and as a result, the nationwide television coverage increased from 20% to 70% of the population by 1985. The successful culmination of the SLV-3 project showed the way for more advanced launch vehicle projects such as the Augmented Satellite Launch Vehicle (ASLV), the Polar Satellite Launch Vehicle (PSLV), and the Geosynchronous Satellite Launch Vehicle (GSLV) in the years to come. The Augmented Satellite Vehicle ASLV program was designed to augment the payload capacity to 150 kilograms, or 3 times the payload of the SLV-3, for putting satellites into the low Earth orbit. While building upon the experience gained from the SLV-3 missions, ASLV proved to be a low-cost intermediate vehicle to demonstrate the valid critical technologies that would be needed for the future launch vehicles. In our next episode of India's eventful space journey, we look at the exciting decade of the 1980s when the first Indian Wing Commander Rakesh Sharma flew into space aboard the Soyuz T-11 with 2 other Soviet cosmonauts under the joint ISRO-Soviet Inter-Cosmos space program. I, for one, was very young, but I still remember so vividly how Rakesh Sharma described India from space. Let's see.
ऊपर से भारत कैसा दिखता है आपको?
जी मैं बगैर किसी झिझक के कह सकता हूँ कि सारे जहां से अच्छा.
How beautifully he put it. And this was truly a historic moment for India and a turning point for India's space program. Now, since the 1980s, ISRO has transformed itself into one of the largest space agencies in the world with a fleet of communication and remote sensing satellites such as INSAT and the IRS. We have become self-reliant in a host of space applications and, importantly, a range of satellite launch systems which are also used by a number of other nations. So in our next episode, we look at advances made in launch vehicles like PSLV and GSLV, space exploration initiatives like Chandrayaan and Mangalyaan, and of course, the current mission Gaganyaan, under which preparations are underway for launching a 3-member Indian crew to space and safely returning them to Earth. This and lots more on our show, Science for a Self-Reliant India, only on India Science.